Hello, Math 1030. This is lesson 11C. Another, I think, pretty short one. Also has only 5 homework questions, just like 11B. So hopefully you'll be able to crank these ones out without too much trouble or time. So today we're talking about proportion and the golden ratio. Um, the golden ratio is this. So if you take a line segment, so we've got this line from here to here. If you divide it according to the golden ratio, then the length of the long piece, the ratio of the length to the long piece um, to the length of the short piece is going to be the same as the ratio of the length of the entire line segment to the length of the long piece. Isn't that fun? So, so what this is saying is that if I take the length of this longer portion and divide it by the shorter portion, that's the same as if I take the whole length and divide it by the longer portion. And both of those, those two ratios are the same, and that ratio is a constant. It is equal to 1 plus the square root of 5 divided by 2, which is about 1.618. So this is called the golden ratio, this number. And the golden ratio is a number that's like pi or like E. It's a transcendental number. It is irrational. It has a decimal expansion that goes on and on forever. For this homework assignment, you're going to either use 1.618 or 1.62, and the homework problems will tell you which of those numbers to use. Okay, but there's not a golden ratio button on your calculator or anything. You'll have to either use 1.618 or 1.62. So both of these ratios are equal to 1.618, and that's called the golden ratio. So we're just going to solve a couple problems using the golden ratio, and that's it. Okay, so a line is subdivided according to the golden ratio with the smaller piece having a length of 8. So the smaller piece is 8 centimeters. Our question is, what is the length of the entire line? Okay, so according to our golden ratio proportion, the longer portion divided by the shorter portion has to be equal to the golden ratio 1.618. So we know how long the shorter section is. The shorter section is length 8. So this equation is very easy to solve for L, for capital L. We would just multiply both sides of our equation by 8. Oops. And so L, capital L, is 1.618 multiplied by 8, which is 12.9. I'm going to round to the nearest tenth on this one. On the next ones, I'll round to the nearest hundredth. So now be really careful, because on this particular homework assignment and on the test, if it comes up on the test or review, a really, really common error is to type in that answer and get it wrong. Because this is not answering the question. This is this part of the line segment, 12.9. So the question is, how long is the entire segment? Well, the entire segment is those two pieces added together. So it will be the 12.9 plus the 8 for the answer of 20.9. So just make sure that you actually finish the question. Don't start or stop too soon and get it wrong. Okay. All right. So we started out talking about, the golden ratio being a way of portioning a line, but we also have something called golden rectangle, and a golden rectangle is a rectangle whose sides have this proportion. So if you take the longer side and divide it by the shorter side, then you get that same golden ratio, 1.618. And if it has that proportion, it's called a golden rectangle. And golden rectangles show up a lot in architecture. It's supposed to be, a really pleasing sort of shape for our eyes. So a lot of things use this kind of proportion. So example 2 says the sides of a rectangle are 5 inches and 9 inches. Compute the ratio of the long side to the short side. And we just need to answer the question, is this a golden rectangle? So we've got a rectangle whose sides are 9 and 5. So what you need to do to answer this type of homework question is do the long side divided by the short side. And you need to get somewhere in the neighborhood of 1.6. Now, you don't have to get 1.618 or 1.62 in order to say that it's golden. You just need to get about 1.6 in that neighborhood. So in this case, if we do long divided by short, we get 1.8, which means that this is not a golden rectangle. As long as you get in the neighborhood of 1.6, you would mark yes. Okay, last example. The length of one of the sides of a golden rectangle is 10.7. Notice that the other side of the golden rectangle could either be longer or shorter. And I have 2 visuals of that right here. We want to use the golden ratio approximation 1.62 to decide what the other sides of the rectangle should be. So starting with if 10.57 is the longer side, we're going to calculate the shorter side. So I prefer when I'm doing these problems, and we'll kind of talk about the shortcut for them, but if we use that idea that the longer one divided by the shorter side has to equal 1.62, we can set up a little quick equation here. So in this case, the longer side is 10.7 and the shorter side is x. And to be golden, that has to equal 1.62. Well, if I'm solving this equation, I would multiply both sides by x. And so we would have the equation 10.7 equals 1.62x. And then, of course, just finish that up but with some division. Divide both sides by 1.62. And we get that x is 6.60. I'm going to round to the nearest hundredth on this one. On your homework, just really watch those rounding statements. Okay, so that's how long the shorter side would be if the longer side was 10.7. So now we're going to switch and think about if 10.7 feet was the shorter side. I'm going to call the longer side y. So again, if we set up our little equation, the longer one divided by the shorter one has to equal 1.62. So this one's actually a little bit easier to solve. We just need to multiply both sides of our equation by the denominator 10.7. That cancels out, and we can punch that into our calculator to get 17.33. There we go. So kind of a shortcut if you don't want to set up these equations every time is that you might notice that if you're looking for the shorter side, you divide by the golden ratio. If you're looking for the longer side, then you times by the golden ratio. So you can kind of use that idea as you're doing your homework. I think you'll do several of these on the homework assignment. Okay, last thing, just kind of for fun, is that the golden ratio is really closely related to the idea of a logarithmic spiral, which shows up in nature all the time, like this shell picture. So if you start with a golden rectangle and you divide it, creating a square, and then if you repeat that process, so if I divide this to create a square, and then divide this to create a square, and divide this to create a square, and so forth. Whoops, I can't do it very well, but I have it over there. Anyway, that creates, if we spiral through that, it creates a really cool logarithmic spiral shape that is something that shows up a lot in nature and with these proportions, and it's kind of crazy and cool and weird. Anyway, that's it. That's lesson 11C. If you have homework questions that are giving you trouble, please, please, please just let me know. I'm happy to help. You can email them to me, you can text me, you can FaceTime me. I've sent you my phone number, but if you don't have it, just email me and I'll send it to you again. Anyway, let me know what questions come up. I'm happy to help you. There are 2 more homework sections after this. Section 12, I think C, and 12D. Those 2 are not going to be on the final. This is the last one that is going to show up on the final. So if you are wanting to start on the final review after this lesson, you could definitely get started on that. Okay, so let me know what questions come up. Thanks.